and then we'll get started, okay? Some definitions to begin. There's this thing called a rational number, okay? And what that means is it's any number that can be written in the form of this. It's m over n. So what I'm saying here is that you got two numbers, m, and n are integers, okay? So anything that's a fraction, okay, fraction is really a rational number, okay? Now, that was what you learned way, way back. Today, I want to talk about rational expressions. And this is a little bit different in the sense that we're talking about any algebraic fraction with both the numerator, okay, and the denominator being what I call polynomials. Now, you might have forgotten what a polynomial is. I think most of you have. Anyone remember what a polynomial is? Or can give me an example of what it would be? More than two terms? Doesn't have to be more than two terms. It could be one term. It could be two terms. It could be three terms. But what type of terms are they?
Values, like x values.
They could be values with x. You're right. So stuff like this, okay? It's, as an example, like this. X squared plus 3x plus 4. That's a polynomial. Okay. So is something like this. 2x minus 5. Okay. So the idea of a polynomial is anything that involves x. Okay. And the careful part here that you need to worry about is that the exponent, okay, for x must be a whole number. Okay. So don't give me any fractions for the exponent for x. Don't give me any negatives. This is then what a polynomial would be, okay? So I want you to look at the following four things, okay? And I want you to say to me, does it look like a rational expression, yes or no? So first of all, think to yourself, is part A, does it look like a fraction, yes or no?
Yes.
Yes. Then look at the individual things on top and on the bottom. Look at the top only. Is that a polynomial?
Yes.
Yes. Is the bottom a polynomial?
Yes.
Yes. Is this a rational expression? Is this a rational expression then?
Yes.
Yes. Good. Okay, so this is a rational expression.
What's an exponent again?
What's an exponent?
Yeah.
This little thing. The square is the exponent.
Oh, okay.
Okay. So yes, this is a rational expression. Okay. Okay, now how about B? First of all, is it a fraction?
Yes.
Yeah, right? Numerator, denominator. Is the numerator a polynomial?
No.
No. Why is it not?
Because you can't have x.
With the no, you can have x cubed, right? Cube is a whole number. That's okay. It's this root x that's the problem. Does anyone remember what root x is as a power back in grade 10? X to the power of 1 over 2, right? See, fraction. Bad news. Okay. So therefore, no. Okay. I'll say although you see a fraction, although you see a fraction. Okay. I'll say the numerator, which is the none at the top, is not a polynomial. Polynomial. And that's because of that x or root x. Okay? Root x, bad news. Bad, bad news. Okay? Okay, let's think about part C for those of you who are ready. Question is polynomial, rational expression, yes or no? How many say yes? How many say no? How many don't know? Okay. Is it a fraction?
Yes.
Yeah, I see numerator, denominator, yes. Is the numerator a polynomial?
Oh, no.
No, because this is to the power of x. This is what they call an exponential, so that's no. Okay? We won't worry about that right now, but that's no good. So once again, no, because the numerator is not a polynomial. Okay. And neither is the denominator, by the way. Okay. Denominator, because it's 1 over x. If you rewrite that as x to the power of, does anyone remember the exponents for 1 over?
1/2.
Close, not 1/2. -1, thank you. So once again, that's not a whole number, so therefore denominator
So if it's a negative number, it's not a whole number?
That's right. Also not polynomial.
Oh, yeah.
Okay. So B and C, no. And then we'll do D. I'll let you think about D. Once again, ask yourself, is it a fraction? And then is the numerator and the denominator polynomials? First of all, is it a fraction?
No. Well, yeah, yes.
It can be a fraction. How would I write that as a fraction? Over 1. Thank you. Right? This is the same thing as over 1. Okay. So now I've turned it into a fraction. Is the numerator a polynomial? Yes. Is the denominator a polynomial?
Yes.
It is. Just as a constant itself, like a number, that's also a polynomial. So yes, this one is yes. Okay. So the first thing I want you to understand here is, hey, we need to know what rational expressions look like. Okay. And now afterwards, I'd like to show you how we can evaluate. So what does evaluate mean? Evaluate means not just solve, but that means plug in the numbers and tell me what this whole thing actually equals to, what this expression is equal to. So the idea is just plug in the numbers. So let's do that. Plug in numbers. For 1a, what do I plug in for x?
5.
5, good. So I'll write down 5, take away 3 times, and the x is 5. What's the y value?
Negative 3.
Negative 3, good. Divided by 5. All right. Go ahead now, ladies and gentlemen, and go ahead and calculate. Okay. Okay, so yeah. So what's 3 times 5 times 3? 3 times 5 is 15. 15 times 3 is?
60. Oh, sorry, 45.
45, right? And then 2 negatives become a positive, so plus 45 all over 5. Okay. And please be careful here. I want you to look at the whole numerator as one whole thing first. So let's do the 5 plus 45 first. What's that? 50. And we'll do the 50 divided by 5. Your answer is just 10. Okay? Now, ladies and gentlemen, can you start to do B and C then? Okay, I would like you to try to put the numbers in. And let's see if you can figure out what it is equal to. Okay? So numbers for part B, let's take a look. Can someone help me out? What number's on top?
4 times 5.
Yeah, what's 4 times 5?
20.
20, good. What's on the bottom then? 5 squared is what, 25? 2 times 5 is 10, times negative 3 is minus 30. Be careful with the last thing here is negative 3 all squared, not 3 squared, but negative 3 all squared. Plus 9, thank you.
It's equal to 1.
Is that equal to 1? What's this equal to?
No,
24?
20, that's negative 4. 5.
5, right?
Yeah.
Okay, good. Got 5, I'm happy. Don't have 5, fix it. Okay, last one. Ah, the funnest one yet. Let's plug in negative 3 for y. Let's plug in 5 for x. And then I have negative 6 on the top. What's 5 minus 5?
0.
0. What's negative 6 divided by 0?
0.
Error. Don't tell me 0.
Oh, you can't divide it.
You can't divide into 0. I have no clue. Error, or what we call in math, is we call this undefined. Okay?
Can we write error?
On your calculator, it will say error. But if you want to be mathematically sophisticated, use the word undefined. Okay. So, we've got problems for some numbers. Okay? And underneath, I said here, in the last example, it says it's not defined when x equal to 5, because it's undefined, right? Not defined, undefined. Why is it undefined? It's because the denominator equals to 0. We can't have that, okay, when we do fractions. I don't know how to divide by 0. So what we have here is a special term. In other words, x equal to 5 is what we call a non-permissible value. Non-permissible means it's not allowed, okay? Doesn't work. Doesn't make sense. By the way, sometimes I'll use this, NPV, for non-permissible value. Okay? So what I wanted to show you today is that these rational expressions work for most numbers except for some. And you have to know how to find out what those bad numbers are or what those not permissible values are. Okay, that's our first step for today. So in example number 2 here, can I ask you to take a look at these expressions and tell me what are the non-permissible values for all of these rational expressions? Okay? Now, how do I find them? Where do I look, first of all, for non-permissible values?
Denominator.
Denominator. Good. Let's look at the denominators. That's 3x minus 4. Okay? And what's the idea here? The denominator can't equal what number?
0.
Good. So I'm going to ask you to do this. Write down the can't equal to sign. 0. Okay? So 3x minus 4 cannot equal to 0 because it won't work. Now, I want you to solve for x. So just like regular algebra, how would I solve for x? What would I do? Add
Plus 4.
Plus 4 to both sides. Good. So we have 3x can't equal to positive 4. And then now how do I solve for x? Divided by 3. So therefore x cannot equal to 4 over 3. That is your non-permissible value, NPV.
So you just cross it out, cross over the equation sign?
Yeah, it's just like making an equal sign, except now because I said not equal to, just put a slash in between to make it not equal to. Okay? That's it. That's the idea. So let's try part B then. If I want to do the same thing for part B, what do I have to look at? Numerator or denominator, first of all.
3x, x minus
Yeah,
7.
it's that denominator, 3x times x minus 7, and I can't make that equal to 0. Is this kind of like chapter 4?
Can you factor it in?
It's already factored, so what do we do here?
Right,
I don't want to
expand.
expand. It's already in factored form. It's easier when it's in factored form.
Oh, divide
What did
by
you do
3x.
in chapter 4 when I had like this times this equals to 0? What did you do? You separate them, right? Make the first bracket equal to 0, make the second bracket equal to 0, and solve. It's the same thing here. So what would I do? I can make this part not equal 0. 3x not equal to 0. So what's x?
0.
Not equal 0. Good. There's one answer. And don't forget the other bracket. X minus 7. That's not equal to 0 as well. So what's x not equal to in this case?
7.
That's right. Done. Do you see why I did this chapter now? Because it really is the same stuff as before. Can you see that? No?
Yes.
Okay. Any questions so far? Ask me if you have questions. Okay, Andrea?
Well, is it 0?
That's right. 0 divided by 3 is still 0. Okay? All right. How about part C then? Can you pass this? So once again, you're looking at the denominator. So we're saying negative 3ab can't be equal to 0. Why don't we split this up into two parts? So we have either negative 3a can't be 0, or from this part, what do we have? B can't be 0. Well, there you go. There's already one answer. B can't be 0. How would I solve for A? Andrea, I'll ask you. What's 0 divided by negative 3? 0. That's right. So therefore, A just can't be equal to 0.
Yeah, I don't get that.
Okay. I'm asking you here, Tanasia, negative 3 times A cannot equal to 0, right? And I'm asking you to solve for A. So I don't want the negative 3 there. This is multiplication. So the opposite of multiplication is division. What happens when I take 0 divided by negative 3? Still 0. So therefore, A can't be 0.
Okay.
Okay? All right. D. I see a square. I see a linear term. I see a constant term. What should I do?
The thing
Yeah,
you
the thing you did, which is called
did. Can't remember.
factor. Remember this idea? Two numbers that multiply to what?
4 and add to
Yeah,
negative 5.
and add to negative 5. All right. Go ahead and try to find the right combination, dear friends. Who's got it? Who's got it? Who's got it? Who's got it? Who's got
Negative 1
it?
and negative 4.
Thank you, Danny. Says negative 4, negative 1. So what happens is that this denominator just becomes m minus 4, m minus 1. And how do we find these non-permissible values again? We look at the denominator and make it
0.
0. Okay, or I'll say not equal to 0. And when you have two brackets like this and it's not equal to 0, separate them into individual brackets. So therefore, m minus 4 can't be equal to 0. And over here, m minus 1 can't be equal to 0. So what's the values for m?
M cannot equal to 4.
Thank you.
And M cannot equal to 1.
Good. So m cannot be equal to 4. M cannot be equal to 1. Those are your non-permissible values for D. The signs have to be opposite, right? Because you're solving for m, you're going to have to move that number from the left side to the right side. Good. Okay. So far so good? The concept's pretty straightforward? Okay, so try E and F then. Okay? Should I give you some time to try on your own? Okay. Give you about a minute to try E and F. And those of you done, you can move on to the next page if you want to. Stop recording me. I think so. I hear it. I saw many of you do this. G squared plus 25 can't be equal to 0. And then you did this. G squared can't be equal to negative 25. And then you did this. You took square root. G can't be equal to, now what's the square root of negative 25?
Undefined.
It's positive?
No.
No.
Can't do it.
It's plus minus? Okay, plus minus of root negative 25. What's the root of negative 25? Try on your calculator. The idea is you can't do it. No such thing. You can't take the square root of a negative number. So what does that mean then? What are my NPVs?
None.
There are none. That's right. What?
So
What?
it could be
Yeah.
anything.
So in this case, there are none or no NPVs. Remember, the idea of NPV is we just want to figure out what values doesn't make this thing work. And we look at the denominator. Well, look, I'm taking a number, I'm squaring it. That's always going to be 0 or bigger. And I'm going to add 25 to it. Will it ever be equal to 0? No. So we don't have to worry about stuff that doesn't work. Everything works. How do you factor g squared plus 25? Don't tell me this. 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 Don't tell me g squared plus 25 equals to g plus 5, g plus 5. Is that what you did? Oh, g minus 5? Okay. What's the problem there? What's 5 times negative 5? That's negative 25. It's not positive. Can't factor this one. Okay? Don't freak out. Okay. Last one, F. Uh-oh.
That one's not even.
This one you have now is the following. X squared minus y squared can't be equal to 0. Can you factor this for me, though?
X minus y, x plus y.
Yeah, this is a difference of squares. This is x minus y times x plus y. This one you can factor, Kevin. The other one you couldn't. See the difference? This is a minus sign, difference of squares. This is a plus sign, sum of squares. Okay, there's a difference. So now how do you solve for this? Well, you make x minus y not equal to 0. And if I asked you to solve for x, what would you do with that minus y? Bring it to the other side. Yeah, so x can't be equal to positive y. Okay. And then the one over here, x plus y can't be equal to 0. What do we do next? Well, we just solve for x and you bring it to the other side. There you go. Done. Any questions for me so far? So that's 4, right? So if you understood that, hey, both of these numbers can be divided by 4, then what's 12 divided by 4? 3. What's 28 divided by 4? 7. Now, is this the simplified form? Can you simplify even further?
No.
No, so you're done. Okay? Now, in essence, what I want you to understand is this is what you did. Okay? What's 12 equal to again? Oh, you said it's 4 times 3. Oh, what's 28 equal to? Oh, that's 4 times 7. You see how there's a 4 on the top and a 4 on the bottom? I guess you just crossed them out, or you divided them out. And you got 1 and 1. What's 1 times 3? That's 3. What's 1 times 7? 7. There's your answer. Okay? That's, in essence, what you did. Okay, let's try part B. What number is multiple for both 15, or not multiple, a factor of 15 and 75?
15.
15? Oh, okay, so I guess you can say the top is just 15 times negative 1. What's the bottom? 15 times what gives you 75?
5.
5. Good. And since there's a 15 on the top and a 15 on the bottom, what do we do?
Negative 1 over 5.
get rid of them by dividing them out, and you're left with your answer, negative 1 over 5. Yay!
This
Okay.
is difficult.
This is difficult?
It's gonna get difficult.
I sucked at this in grade 5.
If you want more practice in fractions, come find me. We'll give you some fractions practice, okay? We'll sit on the carpet too, okay? And we can have a nice little group thing,
Yeah.
okay?
I remember those times.
Remember those days? Yeah,
I
yeah,
want
yeah.
to find you a big booklet of fractions.
I'll give you a big booklet of fractions too. If you like the Kumon method, that's fine. Okay. All right, part C. What number divides evenly into 28 and 44? 4. Okay. 4 times 7 gives you 28. 4 times what gives you 11? 44. 11. Shoot.
You said
I said it.
hey, get out of the
The 4's canceled out. Don't forget there's negative in front. So my favorite store, 7 over 11. No, it's not my favorite store.
It's not even a store.
They rip you off there.
No,
Don't buy chips from 7-Eleven.
it's like $5.
Yes, Superstore.
You can get
Cheaper.
it at Costco.
Or Costco, yes. But you need membership at Costco.
Yeah.
Okay, why am I showing this to you?
Because those are the steps involved in harder equal.
That's right. Angie says these are the steps that are involved with dealing with rational expressions in grade 11. Okay? So what are the general things that we did? What did we do with step 1? Well, we try to simplify the fraction, right? So we try to simplify fraction by finding, I'll say, a common factor. Okay, a common factor, right? The
Is it
4,
greatest common
15.
factor?
Okay, it would help if you found the greatest common factor too. Yeah, you don't have to find the greatest one, but if you do, it just makes your steps much easier. So instead of finding a greatest common, how about finding the greatest, sure, common factor? And then what else do we do once we found that? Yeah, you simplify by, like, I'll say cross out, but really crossing out is not a very good idea. Okay, cross out that common factor and reduce. Okay. Now, let me just tell you, it's the exact same thing when we're dealing with these rational expressions, okay? Exact same thing. Except there's something called step 0. What's step 0? What do we always have to look for? What do we have to be careful of when we're looking at rational expressions? Think back to the previous page. What do we have to be careful of? Those things. What are they called?
Cube roots?
NPV.
NPVs, right. So once again, you must first find all the non-permissible values. Not VIPs. NPVs. Okay. All right. Ladies and gentlemen, if you can understand these 3 steps, step 0, step 1, step 2, life in this section is easy.
Section.
Yes, in this section. 4 sections. Because guess what else you did when you did algebra, or not algebra, fractions? You learned how to simplify, then what else did you learn? How to divide and multiply, good. And then how do you do it?
Sing.
How to sing, okay. Add and subtract, yeah. And then what else?
No.
Stay tuned then. Okay, you'll find out. Okay, let's do example number 3. We won't finish the whole thing today, but we'll try what we can. Okay? Example number 3. State the non-permissible values first. Okay, so let's find the NPVs first. How do we do that?
You do the
Make it not
denominator.
equal to
Make it not equal to 0. What's it?
Divide by 4.
The denominator. Good. Okay. So notice we got 2 variables, an a and a b, so I will split them up into 2 parts. Okay. Either the negative 4a doesn't equal to 0, or the b cubed doesn't equal to 0. Okay. Okay, so let's do the 4a part, the negative 4a. I want to get rid of that negative 4. So I'll take 0 divided by negative 4. What's that?
0.
Still 0. So there you go. A can't be 0.
No, that one's
Now how about the b? I won't want that cube there. So what's the opposite of the cube? Take not the square root, but the cube root. What's the cube root of 0? Still 0. So therefore b can't be equal to 0. Good. Those are your NPVs. Sweet. Okay, now, I want you to simplify that fraction for me.
Okay.
Remember the idea of simplifying? Find common factors. cancel them out. How about the 36 and the 4? What's the common factor between them?
-4.
The 4 or -4. I'll leave the negative there. So I'll say 4. So what's 36 divided by 4? 9. And then 4 divided by 4 gives you?
Negative.
Just a 1. So I'm going to rewrite them as just 9 over 1. Okay? What about this thing now? A squared on the top and A on the bottom. How does that simplify?
A on the top.
Just an A on the top, right. Okay, so I'm going to get rid of that. Just an A on the top. B cubed on the top, B cubed on the bottom. Are they the same thing? Yeah, just cancel them out too, right? So what are you left with?
9 over A.
9A over
-1.
-1 or, bless you, -9A.
Negative 9A.
Would we have to simplify it to -9A, or is it okay if we were
If you leave it as the fraction, that's fine. But if most people don't like fractions, so they just put it as -9A. Okay. All right, that's the easy one. Here comes the interesting stuff from Math 11. 4x plus 12, 2x plus 6. Oh, let's find the NPVs first. Yeah, let's do that first. What's the NPV?
6. Wait, it can't be equal to 3.
Yes, careful, not 3. Okay, you make the bottom not equal to 0. I think it's -3, yeah. So 2x can't be equal to -6. X can't be equal to -3. Good. Okay. Yes, Kevin. Well, you need to understand that not these fractions don't work for every number. There are some numbers that don't work, and you need to be cognizant and understand that. Right now, you won't see the benefits of this, but later on in the chapter, you will. Okay? But right now, I want you to get in the habit of finding these NPVs. Okay? Okay, how do you simplify this?
2x.
2x.
Oh, the 4x divided by 2x is a 2.
Okay, watch. Watch me first, okay? Don't write this down. Watch me. Some of you will be tempted to do this. Ooh, 4x, 2x, x is canceled out. 4 and the 2 become 2 and a 1. That's 2. And then you'll be like, oh, 12 and the 6, that becomes what? 2 and 1. 2 plus 2 is 4. Okay, that's what you'll say. That's like you saying this. Here's the fraction 3/5. That's the same thing as 3 plus 0. That's the same thing as 3 plus 2. Oh, look. That becomes 1. Oh, look. This becomes 0. Yeah. Okay. If you want to make up your own level of math and sell it to someone, go ahead and try. 3/5 doesn't equal to 1 in my life. I hope it doesn't equal to 1 in yours. So, here's my advice to you. Okay? When you get a question like this, the plus sign here makes a difference. Okay? When it's a plus, you can't cross out. Okay? You can only cross, reduce, and simplify when you see multiplication. Okay? Timesing. Not plusing. Timesing. Is that a word? Timesing? Multiplying. Okay, multiplying. So here's what I'd like us to do then. Okay? Listen up now. Start writing this down. What should we do to try to simplify?
Just leave it like that.
You can't just leave it like this. Do you see anything that you can factor? Look at the numerator. What's the common factor between 4x and 12? 4. Factor, please. 4 bracket, what's left over? X plus 3. Why would I do this? Well, now, do you see there's multiplication? 4 times x plus 3. Okay, multiplication. How about the denominator?
2x plus 3.
Once again, there's a 2. Yes, yes, yes. 2. And then, oh, look, it's the same thing, x plus 3. Multiplication, multiplication. Now you can simplify. Okay. How about the 4 and the 2? What does that simplify to? 2. What's the x plus 3 and over x plus 3? Well, they're the same thing, so we reduce them to 1 and 1. So what's the answer here? Just 2 times 1, or that's just equal to 2. Okay? That's why I said your favorite word in chapter 6 is? No, factor. Factor. Think about it all the time.
Why did you do 2 times 1 though?
I just want to show you that this actually equals to 1.
I know that, but shouldn't it be 2 over 1?
Sure.
It's the same
The
thing.
same thing. That's still 2. 2 over 1. Same thing.
Divided by 1.
Okay, ladies and gentlemen, part C. Guess what you need to do?
So,
Back to the top.
Factor. Factor the top. Factor the bottom. But before you do that, Ryan says NPVs first. You're right.
Oh, damn.
Okay, now, to help you out with the NPVs, I would still suggest that you factor first. Because that denominator of x squared minus 4, if you factor it, it actually makes it easier for you to find the NPVs. So let's just see if we can factor this thing first, okay? Can someone help me with the numerator here?
x minus 5x plus 4.
Right, you want two numbers that multiply to negative 10, those same two numbers that add to negative 3. Okay, so let's think about that. What two numbers multiply to negative 10? Those same two numbers add to negative 3.
Negative 5 and 2.
Negative 5 and positive 2?
Yeah.
Sure, so that's x plus 5, x minus 2. Okay.
No, it's x minus 5. X plus 2.
Oh yes, thank you. Right, you want negative 3, so my apologies. X minus 5, x plus 2. Thank you. Okay, how about the x squared minus 4?
X minus 2.
Yeah, x minus 2, x plus 2. Right, difference of squares. Right, Kevin? Difference of squares. Okay. Now, once again, why would I do that first? Because now I think it's pretty easy to find your NPVs.
Initially, isn't it
Yes.
supposed to be x minus 2 and x minus 2 since you want it to equal to negative 4?
No, difference of squares. It's the a plus b, a minus b. If you had them the same, that'd be they call it perfect square. You'd have 3 terms.
But does that difference of squares apply if it's x squared plus 4?
No. Remember x squared plus 4, like the previous example on the other page? Remember this g squared, this one, plus? Plus means you can't solve, so you can't factor that either. Okay? All right, back to here. What are the NPVs then? So I look at my factored form of the denominator to help me find my NPVs. Either x minus 2 can't be equal to 0, therefore x can't be equal to 2. Or what else do I have?
Negative 2.
X plus 2 can't be 0, so therefore x can't be equal to negative 2. Yeah. So 2 NPVs. Okay. And then, ladies and gentlemen, can we simplify here to try to figure out the simplified form? Do you see anything the same in the top and the bottom that we can cancel out or cross out?
X.
X what? X what? Remember, you have to take the whole thing. It's multiplication. You see, it's two things.
So
It's
x
x
plus
minus
2.
5, x plus 2. They're not separate. Not x and 2. They're combined together. Brackets make a difference.
X plus 2.
That's right. There's a bracket of x plus 2 on the top and another one on the bottom. We'll simplify that to 1 and 1. So what's left over as our final answer here? X minus 5 on the top, x minus 2 on the bottom. Done. Okay. All right. You try D. And then there's E and F, which are even more tricky. And I think I might actually stop after that for today. Okay. Once again, factoring U. Okay, so try the next one, please, on your own.
How do you do this one?
Gentlemen, D. I hope many of you could factor this, and this is what you should have factored it into, 3x and x plus 3. Once again, I believe that once you have it in the factored form, it's easier to find your non-permissible values. Okay? Shh, quiet please, everybody. So once again, we make this not equal to 0. Therefore, that first part, 3x can't be equal to 0, or x can't be 0. Or we take a look at this next part, x plus 3 can't be 0, therefore x can't be equal to negative 3. Those are your two NPVs. Yes? Good. Now, how do you simplify? Once again, what's common, or what can I cancel out? Well, I see an x on the top and an x on the bottom, so goodbye, goodbye. That's a 1 and a 1. Anything else I can simplify here?
Could have done like 3x.
6 and a 3.
The 6 and a 3. 6 and a 3 simplify to?
2.
2 and a 1. Good. So what's left over? There's a 2 on the top, right? 2 times 1 is 2. And on the bottom, it's 1 times x plus 3, or I'll just write down x plus 3. That's it. Done. Okay. E. Star this one. Start because it's important. And guess what? You'll see it again. And if I was a mean, nasty teacher, I'd put on your test. Right?
Anyway.
Am I a mean, nasty teacher?
You're not a mean math teacher, but you'll still do it anyways.
Oh, okay. All right, here we go. Are those two things the same on the top and the bottom?
Yes.
No, they're not.
Kind of. The numbers are there, the 5 and the x, but the order is different, and so are the signs.
Oh wait, no, they're not.
So you can't go like this, and the answer is 1. No, you can't do that. They're not the same. How can we make it the same? Here's a little trick. You see how everything's kind of reversed around? So what I'm going to ask you to do is try to unreverse it by factoring out a negative 1. Okay? I'm going to ask you here to factor out the negative 1. Now let's see what happens. Okay? What's 5 divided by negative 1?
-5.
That's negative 5. Good. What's negative x divided by negative 1? Just a positive x. Okay? Now the bottom's still the same. Okay? Now, notice here I've got negative 5 plus x. I can actually now switch the order. I can just rearrange. So I'll say rearrange to have the following. Negative 1 on the top. And instead of having negative 5 plus x, I'm going to rewrite this as x minus 5. Same thing, okay? Same thing. Why do you think I did that? Yeah, so you can simplify now. Look, now you have an x minus 5 on the top. Now you have an x minus 5 on the bottom. They simplify to a 1 and 1. So what's my final answer here going to be? Negative 1. That's it.
What about NPVs?
Oh yes, NPVs, thank you. What's my NPV then?
0 and 5.
0?
Just
No. 0's not it.
Oh, 5, sorry.
Right, x minus 5 can't be 0, so therefore x
You-
can't be equal to 5.
Yeah.
Good. Okay. And I've got just enough time to do F. Help me out, help me out, help me out. What is
-x.
the top? That's 7 minus x, 7 plus x. Sure, that's good.
X
What?
-8.
Right, difference of squares in the top, right? 49, the difference of squares. Okay. How about the bottom?
X -8, X -7.
Yeah, quickly now. Remember two numbers that multiply to 56. Those same numbers add to negative 15. X minus 8, x minus 7. By the way, if you're having trouble still with factoring, come find me, please, and I'll help you individually. Okay? If you can't factor, you're not going to like this chapter either. Okay? Once you've got this, I think now I can find the NPVs. Okay? I'm not going to show all the steps now. Can someone just tell me what they are?
8 and 7.
Yeah, just can't be equal to 8, can't be equal to 7. Remember, we just switched the signs.
Wait, what?
We just switched the sign, right? This is x minus 8, so it becomes
Oh, yeah.
can't be 8. Okay, now once again, we're going to try to simplify here. 7 minus x on the top, x minus 7 on the bottom. Almost the same.
Put the -1.
Just like before, what do we need to do?
Put the -1.
Let's just rewrite this, okay? So 7 plus x, and let's rewrite that part as -1, and then what goes inside the bracket there?
-7 plus
-7 plus x, sure.
Or X minus 7.
Okay, or x minus 7, yeah, your choice. Okay, and then I hope now you can see that this -7 plus x and this x minus 7 are the same thing, so we cancel them out. So what's left over? A -1 bracket 7 plus x on the top, and what's on the bottom?
X minus
And x minus 8. Bravo. Okay?
You can simplify the top.
If you want to simplify the top by distributing the negative, you can. But if you don't want to, that's fine as well. I'll take both answers. Not a problem. Okay? All right, ladies and gentlemen. So, yes, Andrew. Right now, NPV doesn't help you much at all. Yes, you will find out later on in the chapter, but I'm hoping that you will get in the habit of finding the NPVs so that when you get to where it comes in handy, you'll understand and realize why it happens. Okay? By the way, don't pack up yet, dear friends. Here's your homework, okay? Let's not do all of this because I haven't taught you everything yet. Let's see what I can give you to do. Page 317. 1 to 4. That looks good. 6 looks good. 8 looks good. 9 looks good. 11 looks good.
6, 8,
13 looks good. Let's stop here, okay? Can you do these questions up to number 13 for me for next day?